So hello guys, welcome to video once again. So continuing from the lever, we're studying about lever. Before we studied that lever is a rigid bar which rotates around the fixed point called fulcrum. So this is the fixed point over here about which the lever rotates. The lever rotates as I showed in the previous video. There are some few terminology in lever. Whenever we are studying about the lever, we need to learn about this terminology. That is first of all of load. So how do you define load? Whenever we are doing work in a machine, some object has to be lifted. If I take this example of scissor type of thing over here, which is fulcrum here, and this has to be lifted up, we have to apply force on the machine to lift some of the object, which is simply known as load. And load is always measured in terms of Newton. The SI unit of load is Newton, since it is a type of force only which has to be overcome in a machine. Next one is effort. So how we define effort? The force which is applied on a machine to do work is known as simply effort. Once again, since it is a force, its SI unit is Newton. Keep in mind about the SI unit of load and effort. Both of them have the same unit, that is Newton. Now talking about next quantity, that is the distance between effort and the fulcrum is known as effort distance, which is simply represented by ED. This is also known as effort distance over here. Fine, my guys, which is simply represented by ED, and this will also be called as effort of effort, right? Let's go to next one. We've got load over here, a heavy Newton. Let's say that it's around 50 Newton, which is almost 5 kg. The distance from fulcrum to the load is known as load distance, or it is also known as load arm. As we discuss about load arm and effort arm, there are a few other terminology which explains about the lever. What is the role of lever, whether it is force multiplier, whether it is whether it is force multiplier, or whether it is increases the speed of doing work, or simply it changes the direction. This kind of things we see in case of lever. So how do you identify whether a machine is force multiplier, effort multiplier, or increases the rate of doing work, or it changes the direction? For that you have got just three concepts. If in a machine, in a simple machine, if effort distance is greater than load distance, it is regarded as effort multiplier, which is also known as force multiplier. Next one is if load distance is greater than effort distance, then this is regarded as speed multiplier, or you can say that it increases the rate of doing work. These are totally based our session is totally based upon the exam point of view. Okay, and finally, if load distance equals effort distance, then this kind of lever is regarded as which helps in changing the direction of force. Simply changes the direction of force. Neither it is effort multiplier nor it increases the rate of doing work. Okay, these are the key points. This can be asked in MCQs and all, so remember this key point over here. It is going to be helpful for you all people. Okay, now moving on to Oh, next terminology, that is MA, mechanical advantage, which is simply represented by MA over here. It is the ratio of load by effort. Since it is the ratio of similar quantities, that is force. Load is also force, effort is also force. If I express their unit, I write over the Newton, which will get cancelled. As a result, MA of a machine becomes unitless. Guys, it's time to have a cup of tea. I'll teach you people along with cup of tea, okay? Wow, fantastic. Okay, back to our topic, guys. We're over here discussing about MA, that it is unitless quantity. It doesn't have any unit. Then, what kind of idea does MA gives? MA simply says that by how much is effort multiplied by a machine. This idea is provided by mechanical advantage. For your reference, if I say that MA of a machine is 2, then we simply understand that by using this simple machine, we can, sneezing, sorry. MA equals to 2 means we simply understand that this given simple machine multiplies the effort by 2 times, which means if I keep over here load of 200 Newton, the machine whose MA is 2, just by applying force of 100 Newton, we can lift this load of 200 Newton. This property of machine is defined by mechanical advantage. If we say that MA of a machine is 1, then this machine is not going to multiply the effort. For a machine to multiply effort, its MA must be greater than 1 every time. The next very important point about mechanical advantage is that MA is affected by friction. Affected by friction, my dear people. Because in a machine, the machinery parts are in contact with each other. At the region of fulcrum, if you look at the seizure, you find that all the components of machine, they are in contact with each other. And we have studied that if any of the two bodies are in contact with each other, and if they in case move, then friction is produced at that point. So some amount of effort that we applied into the machine, that is reduced by the friction. As a result, we say that MA is affected by friction, because some amount of force applied in a machine is reduced by friction that exists between the parts of machine. As a result, we say that MA is always less than we have expected. For example, to lift the load of 200 Newton, let's say if I apply just 50 Newton over here, this is the A4 and this is load over here, then MA, we get this as load by effort, which is supposed to be 200 by 50, that we get 40 Newton, 4 Newton over here. 4, the MA is supposed to be 4, but it is actually less than 4, almost around 3.8 or nearly 3.9. Why is this? Because due to the friction that exists between the machinery parts, the MA is always less than expected. This much for today's class. about MA. In the next class we shall discuss furthermore. Till then, bye bye, take care.